Please let me know whether this presentation is visible, the first page of this presentation.
Yes, sir.
Yeah, thank you. So good morning one and all. So this is the continuation of module number 4, that is CAMS. Okay, so this will be your class number 4.9, and this will be your last lecture on CAMS. So in today's class, we are going to solve one more problem on a roller type of a follower. So you can see this roller type of a follower. Again, the procedure to draw the displacement diagram and the cam profile is same. And what is the specialty of this problem is, so you can see, so this is the a roller type of a follower, right? And this is the cam profile. You need to draw this. So you can see this is the vertical axis, which means the axis which is passing through the center of the base circle or the cam, and so this is the axis of the follower. Okay, so this is the axis of the follower. So, and you can see there is an inclination of 30 degree. It means the follower is going to move in a up and down direction at an angle of 30 degree with respect to the vertical axis. Just wait for a second. I think there's a problem with the cursor. So please observe this pointer. You can see the axis of this follower is at an angle of 30 degree with respect to the cam axis. It is the only difference compared to the previous problems. Okay, so we'll get started with today's problem. Yeah, so please note down problem number 7. So first I'll read out the complete problem, and after that I'll note down the given things. After that I'll go with the displacement diagram, then finally cam profile. So the problem states that a push rod operated by cam is to rise and fall with simple harmonic motion. Okay, so there is a follower and there is a cam, and it has to rise and fall with simple harmonic motion. So it is clear. So both the rising and falling of the follower is with a simple harmonic motion along an inclined straight path. It means instead of oscillating in up and down direction, it is moving at an angle of 30 degree. So it is moving like this. Okay, at an angle of 30 degree. That is the only difference. And the least radius of the cam is 50 mm. It is given. It means the minimum radius or the least radius is nothing but the base circle radius, which is nothing but 50 mm. And the push rod is fitted at its lower end with a roller of 30 mm diameter. So it is given. So this is a push rod or the follower. So it is fitted with a roller. It means the type of follower is roller follower, and its diameter is given as 30 mm. Okay. Remember, the diameter of the roller is 30 mm. It means the radius will be 15 mm. Okay. And when it is at the lowest position, it means when the follower is at the lowest position, the roller center is vertically above the cam axis. Okay. So you can see now it is at a lowest position. It is not moved to the top position. It is at the lowest position. At this point, the axis of this roller, so this axis and the axis of the base circle of the cam is same. Okay, it means the axis of the this base circle of the cam, it passes through the center of this roller at the lowest position of this push rod. That is the condition. It means as the cam starts rotating in a clockwise direction, what happens? This follower will move in this direction at an angle of 30 degree with respect to vertical axis. It will move like this. It will move like this. Please observe this cursor. So at that point, the center of the roller will be different when the follower starts moving in upward direction like this. The center of this roller will not be same as the cam axis, and the follower is at the lowest position. So you can see the axis of the cam. So this is the axis. Okay, it passes through the center of the roller. That is the condition. And so the maximum displacement of the roller is 50 mm. Okay, it means the stroke length of the follower is 50 mm. That is S. It means the distance that is traveled by this follower is 50 mm. From this point to this point, it can move up to maximum 50 mm displacement. So which is nothing but the stroke length of the follower. So it is also given in a direction inclined at 30 degree to the right of vertical. So this is the vertical axis, and towards my right means I'll take this angle 30 degree. So instead of for the previous problem, you can see the follower axis and the cam axis is the same in the vertical direction, but here it is slightly tilted towards right. And the cam rotates at 100 rpm in clockwise direction. It is clearly given. Okay, the speed of the cam is 100 rpm, 100 revolution per minute. Per minute, it revolves at a speed of 100 number of revolutions in a clockwise direction. And the time of lift is 0.15 second. It means the time that is taken by the follower to lift from this position to this position is given as a 0.15 second. Instead of giving angle, they have mentioned the time taken by the follower to rise completely. That is 0.15 second. So this is also very important from exam point of view. Please note on this. And the time of fall is 0.1 second. Okay. So 0.15 means it is moving slowly compared to the fall. The fall is very fast. Within 0.1 second, it is coming down. Okay. So the follower is coming down in a downward direction. So in a time of 0.1 second. And with a dwell of 0.05 second at the upward position. Okay. And the follower moves in upward direction. After that, it will take a rest. There is no movement for an interval of 0.05 second. It will take a rest 0.05. So first it will rise 0.15. It will take time 0.15. After that, it will take rest, that is 0.05. Immediately after 0.05 second, it will come down in a time span of 0.1 second. So for these conditions, you need to draw the cam profile. Okay, I'll explain once again in the given data. So please note down. So the type of follower is a roller follower because the roller diameter is given. And you can see the roller follower axis is at an angle of 30 degree. So this is very important. Okay, so this is the highlight of this problem compared to the previous problems. So definitely you'll get this kind of problems when the question paper is very difficult. Okay, please note on all the things. And this is given the stroke length, that is the maximum displacement, that is 50 mm. It's also called as a lift of the follower. And the least radius or the minimum radius is given as 50 mm. You can see this, the capital R, which is nothing but the base circle radius. And the roller diameter is given, that is 30 mm. I want the radius because I want all the dimensions in the radius in itself, because I have taken the base circle in the radius itself. It means when you convert, it will become a 15 mm. It will become 15 mm. Just wait for a second. And after that, whenever the type of follower is of roller follower, there is one more circle, that is prime circle. Whenever the type of follower is of a roller follower, so you can see this comes into picture, that is a prime circle radius. So this will become a reference. Instead of base circle, you need to consider this one. Okay. So the prime circle radius is nothing but the summation of base circle radius and roller radius. Just take the summation, that is 50 mm base circle radius, and the roller radius is 15 mm. Okay, it means the prime circle radius becomes 65, and the speed of the cam is given as 100 rpm in clockwise. After that, the time of ascent or outstroke, whenever the follower is moving in upward direction, it is also called as ascent. And the time it has taken is 0.15 second. I'll denote with T0 or TO, time for outstroke, that is 0.15 second with simple harmonic motion. And time of upward dwell, after reaching the top position, it will take a rest for 0.05 second. It is given in the problem. The first dwell is for 0.05 second. I can denote with T dwell 1, means first dwell timing. And after that, it will come down. After reaching the top position, it will take rest. Again, it will come down in a time interval of 0.1 second, which is nothing but time of descent. The follower is coming down. The return stroke, that is denoted with the TR, that is 0.1 second. It is also with simple harmonic motion. Both are simple harmonic motion. So please let me know if any doubt in this given data, so that I can go with the next step. Anyone, please reply. If it is clear, you can say yes. Yeah, so I think
Yes, sir.
okay, I think this is clear. I'll go with the next slide. Yeah, so I need these angles, the outstroke angle, the first well angle, return stroke angle, and the second well angle to draw the displacement diagram as well as cam profile. But the angles are not given. Instead of that, I know the timings. Time for outstroke, first dwell, and the return stroke. Okay. So please note on this formula to find out the angle, the rotation of the cam, the angle of rotation of the cam. So whenever the time of the follower is given, the time travel of the follower is given, and you know the angular velocity. So omega is nothing but 2 pi n by 60. I know the speed of the cam, okay, that is 100 rpm, and t is given. Okay, so using this formula, I'll calculate the outstroke angle theta naught, first dwell angle, return stroke angle, and the remaining will be the second dwell angle. I'll use the same formula, that is a 360 into n by 60 into t naught. So n is 100 rpm, and t was given as the time required to reach the top position. Okay, 0.015. Just calculate whether you'll get the 90 degree or not. Please check. Yeah. So after inputting all the values, that is the speed of the cam and the time interval, I'll get 90 degree, which is nothing but the outstroke angle, which is corresponding to the outstroke time period. Just wait for a second. Yeah. And after that, I know the time interval for the first bell, that is 0.05. It's given in the previous slide. You can see this is the 0.05. I'll input in this formula. Again, the formula remains same, 360 into n by 60. Only the time will be different. After inputting all these values, I'll get a 30 degree. It means for the first 90 degree of cam rotation, the follower will be moving in a upward direction, that is outstroke. That's why it's called as outstroke with simple harmonic motion. And for the next 30 degree, there will not be any motion of the follower. The follower is under rest. And finally, theta r, again use the same formula, 360 into n by 60 into tr. I know tr, the time required to come down to its original position, that is 0.1 second. I'll get the angle as 60 degree with simple harmonic motion. Means for the next 60 degree, the follower will come down. For the next 60 degree of cam rotation, the follower is coming down. And I want the final angle, theta d2. Its time is not given, but I know this formula. The remaining will be the summation of all these three angles minus 360. 360 minus summation of all these three angles, I'll get 180. Total 360. Okay, 90 plus 30 is 120. 120 plus 60, 180. 180 plus 180, 360. So after finding all these angles, this is a very important slide from the exam point of view. If you don't know how to calculate these angles, you cannot progress. You cannot draw a displacement as well as cam profile. And after that, I'll go with the displacement diagram. I'll complete this in a short time of interval, because already you know how to draw this displacement diagram. The type of follower motion is a simple harmonic. Again, I'll take the scale as 1 centimeter is equal to 20 degree along the x-axis. 1 centimeter means 20 degree. 2 centimeters, 40. Along the y-axis, I'll take 1 centimeter as 1 centimeter itself, stroke length. I'll indicate the stroke length along the y-axis. It means the distance that is traveled by the follower, okay, from 0 to 50 mm. And along x-axis, I'm plotting a cam rotation from 0 to 360. I want total 360. I need to indicate 360. It means 360 by 20. It becomes 18 centimeters. Yeah. So first I'll indicate 18 centimeters along x-axis, because total I want 360. And along y-axis, so what is the stroke length? The maximum is 50 mm. It means 5 centimeter. So this is a 5 centimeter, right? And after that, I need to indicate the first angle. What is the first angle? So please remember this: 90, 30, 60, 180. Okay, 90, 30, 60, 180. Yeah. So first, I need to indicate the first outstroke angle, that is 90. As per the scale, 90 by 20, it becomes 4.5 centimeter. So first, I'll divide this total 18 centimeter into 4.5. So this corresponding to the outstroke angle with simple harmonic motion, that is 90 degree. After that, the first dwell angle is the 30 degree, 30 by 20. How much it is? 1.5. Okay, the first dwell angle. After that, the written stroke is for 60 degree, 60 by 20 is 3 centimeter. So you can see 3 centimeter. That is the written stroke with a 60 degree with a simple harmonic motion. And the remaining is 180. Remaining is 180. 180 by 20 is 9 centimeter. That is the second dwell angle. Okay. And after that, I need to divide this outstroke and the written stroke into 6 equal parts. The outstroke is with a 4.5 centimeter. I want 6 equal parts. So 4.5 divided by 6, it becomes 0.75 each. Just divide this 4.5 centimeter into 6 equal parts, and each division will be 0.75. 0.75, 0.75, 0.75. And give the namings, that is 0, 1, 2, 3, 4, 5, 6. The similar manner, just divide this written stroke also, that is 3 centimeter. 3 by 6 is 0.5. So each division will be 0.5. So again, give the naming in the reverse order, that is 6, 5, 4, 3, 2, 1, 0. And after this, the type of outstroke motion is a simple harmonic, written also simple harmonic. So I'll use a semicircle method. I'll take this stroke length, that is 50 mm or 5 centimeters. I'll take the midpoint, that is a 2.5 centimeters from this reference line, reference origin. So using the compass, I'll draw a semicircle, the radius of 2.5. So this will be the center. This is 2.5. This is 2.5. After that, I use the protractor. Just keep the protractor over here and start dividing the semicircle into 6 equal parts. Total is 180. 180 by 6 is how much? 30 degree. Yeah. Use the protractor here. Just place the center of the protractor here towards your left and just indicate the angles 30 degree, 30 degree, 30, 30, 30 over the circumference of this semicircle. And give the namings A, B, C, D, E, F, A, B, C, D, E, and F. Okay. After that, just join from these 6 points to the center of the semicircle. First one, second, third, fourth, fifth, okay, and the final 6th. I got 6 equal parts, each of 30 degree. And after that, I'll start drawing the horizontal lines from point A, B, C, D, E, F. And these horizontal lines will intersect the vertical lines, that is 0, 1, 2, 3, 4, 5, 6 at certain point. First horizontal line and the first vertical line. So first you can start with here also, here also. Okay, first I'll draw all the horizontal lines. Okay, so you can see the blue color lines. If you want, you can zoom in. So this is the first horizontal line that is coming from point A. It will intersect the first vertical line at this point. So this will be 1 dash. The second line and the second vertical line, 2 dash, third horizontal line, the third vertical line, 3 dash, 4 dash, 5 dash, 6 dash. In a similar manner, okay. So I got these intersection points. There is a blue dots. I got the namings also 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. The similar manner, the outstroke or the written stroke is also with a simple harmonic motion. So I'll use the same semicircle to indicate the intersection points. So this is a dwell. Okay. So for the next 30 degree, there is a dwell. It means I'll draw a straight line. Okay. Before that, so this is the written stroke. That is a 60 degree. It will start from here. So the first horizontal line. So this is nothing but the first. The sixth line, sixth vertical line. So this will be 6 dash, and whatever the line that is coming from point E, and the fifth vertical line, it will be 5 dash, 4 dash, 3 dash, 2 dash, 1 dash, and finally 0. Okay. Please zoom in your mobile screen so that you'll get a clear idea. So I got all the intersection points. Now I'll draw the smooth curve passing through all these 12 points. Yeah. So this is the curve when the follower is rising in upward direction during the time period of during the rotation of 90 degree. For the first 90 degree of cam rotation, the follower is traveling through these distances. So you can see this can approximately say 1 centimeter, 2 centimeter, 3, 4, 5. And after that there is a dwell. So I'll draw the horizontal line here because there is a moment for the next 30 degree of cam rotation. After that the follower will come down. It means the curve has to come down like this. Finally, after that, after reaching the downward position, again there is a dwell. For the next 180 degree, there will not be any motion of the follower. Yeah. So this is the rise, first dwell, return, and the dwell. So this is so please mute your audio. Please mute your audio. So after completing this displacement diagram, so I'll go with the cam profile. Okay. Again, the procedure is same. Whatever you have followed for other problems, it is again it's same. You need to transfer all the displacement distances. That is 1 dash, 2 dash, 3 up to 6 dash with respect to the outstroke as well as the return stroke. Only change is you need to indicate all these dimensions over a line which is at an angle of 30 degree with respect to the axis. So I'll explain this. Okay. These are the steps you can read out after the class. I'll follow the same steps. The first, I'll indicate the center of the circle, that is O. And after that, I'll draw the base circle, that is the radius of 50 mm at 5 centimeter. And after that, I'll draw the prime circle also. So with a radius of 65 mm or 6.5 centimeters, correct? And I'll indicate the axis of base circle as well as the prime circle. This is the vertical axis. And as I said, when the type of follower is roller follower, the reference will be this prime circle. You need to indicate all the values on this prime circle only, not the base circle. So first I'll indicate the point A on the place where the vertical axis intersect the prime circle at this point. This cam axis or the vertical axis will intersect the prime circle at this point. So this will be the first point, the initial point of the follower. At this point, I'll draw a roller. I'll indicate the first position of the roller. And it is given the roller diameter is 30 mm. I want radius, it becomes 15 mm. Just take the center as point A with help of a circle. Draw a roller, the radius of 15 mm or 1.5 centimeters. And it is given the follower axis is at an angle of 30 degree with respect to the cam axis, right? Use the protractor over here, just indicate 30 degree, just indicate the follower axis to certain distance. After that you can indicate the follower. Only this is the difference. When you compare with the previous problem, only this is the difference. Instead of a vertical axis, it is having an axis which is inclined at 30 degree with respect to the cam axis. So only this is the difference. Please make a note. And after that, I'll join point O and point A. So this will become the first reference line. Okay. And it is given the cam is rotating in a clockwise direction like this. Okay. Cam is rotating in a clockwise direction. It means I need to indicate the angles in a counterclockwise direction. Towards my left, I'll start like this. Okay. First angle is 90, that is outstroke. I'll keep the protractor over here. So here, I'll indicate the first outstroke angle in an anti-clockwise direction, that is 90 degree. And I'll indicate the points on the prime circle only. AOB is the outstroke angle, that is 90 degree. After that, I'll keep the protractor here, and the next angle is 30 degree. That is the first well angle, that is BOC. Whatever you have calculated using the formula, that is the first well angle is 30. Again use the protractor, just continue. The next angle is 60. So this will be automatically 60. Yeah, that is angle COD. The written stroke angle is 60 degree. And the remaining 180 will be the second well angle. That is DOA. So this will be the second well angle. 90, 30, 60 and 180. After indicating all these angles, I need to divide this prime circle between point A and point B. That is covered by 90 degree. I need to divide this part of the prime circle between A and B, that is covering 90 degree, into 6 equal parts. Correct? Just calculate how much it is. 90 by 6. 90 divided by 6 is 15. Okay. Use the protractor. Just divide this prime circle into 6 equal parts, such a way that the angle will be 15, 15, 15, like this. You can see this angle will be 15 degree. 15, 15, 15, 15. And these are the radial lines. These are the radial lines which are converging at the center of the circle. And these are the points on the prime circle, not the base circle. And you can give the naming. There is 0, 1, 2, 3, 4, 5, 6 on the prime circle. After that, just extend these radial lines. Before that, I'll divide this also. Before I'll extend this, I'll divide this written stroke also. It will become much more easier. That is COD. It is a 60 degree. 60 by 6, which means 10 degree each. I'll divide the prime circle between point C and point D into 6 equal parts. That is, the 60 by 6 is 10 degree each. And give the naming as 6, 5, 4, 3, 2, 1, 0. This is for rise, this is for the fall. This is the first well angle. I'll not divide this because I want only the divisions of outstroke and the written stroke, not for the first well, not for the second well. After that, I'll extend these radial lines, which are nothing but the blue color lines, which are corresponding to the outstroke angle, into certain distance. You can take any distance. You can see the dotted lines. These are nothing but the extended lines along the same direction, along the same angle. And here you just make a note. Since the follower axis is at an angle of 30 degree, okay, I need to shift these extended lines towards right by 30. Okay. So in the previous case, you have seen the follower axis is vertical, correct? So in that case, no need to divide. Directly I can transfer the distance 1, 1 dash, 2, 2 dash, 3, 3 dash on these extended lines. But since in this case the follower axis is inclined at 30 degree with respect to these radial lines, this also radial line. Now it is vertical, but it is passing through the center of the circle. It means these are the radial lines, correct? So you have to shift these radial lines towards right by 30 degree. Okay. So please keep the protractor over here. Take this as a reference line. Just indicate 30 degree. Before that, I'll extend these also. I'll extend these radial lines corresponding to the outstroke, the written stroke also. As you can see here. So I extended these lines also. Okay, in a similar manner. And I'll shift this extended line, there is a dotted line, towards my right by 30 degree using the protractor. So this angle has to be 30 degree. Just keep the protractor here like this. Take this as a reference. Just indicate 30 degree. Similarly, just shift this extended line, that is a dotted line, towards right by 30. This is also 30. This is also 30. Similarly, just shift all these dotted lines, are the radial lines, by 30 degree towards your right. This is also 30 degree. This is also 30 degree. If you want, I'll show once again. So these are the radial lines. I need to shift by 30 degree towards my right. Use the protractor. Just draw from this point. Just draw 30 degree line with respect to this reference line. Similarly, just shift this also towards right by 30. So this angle will be 30, 30 degree, 30, 30 degree, and 30 and 30. In a similar manner,
Sir,
just
why 30 degree follower?
because this follower is not a vertical, it is making some angle. When you compare the previous problem, the follower will be moving in up and down direction in a vertical manner. But in this case, it is inclined by 30 degree. It is not straight. This axis is not vertical with respect to this
It is
axis.
given in the question.
It is given in the problem. If you want, I'll show this. Yeah. You can see the displacement of the follower is 50 mm in a direction inclined at 30° to the right of vertical. It is given. If it is not mentioned, you just follow the same method similar to the other problems.
Okay, sir.
Okay. I'll take another 5 to 10 minutes to complete this problem. So these are the 30-degree lines. Okay. After that, you can erase these dotted lines. I don't need these dotted lines. Okay, I'll erase this. I want only these 30-degree inclined lines. On these lines, on these inclined lines, I can call it as inclined lines. I'll transfer the distances from the displacement diagram. That is, I'll take the reference as 1, which is on the prime circle. I'll go to the displacement diagram. Yeah. I'll copy these distances, that is with respect to the outstroke, 1 1 dash, 2 2 dash, up to 6 6 dash using a compass. I'll copy these distances from the reference 1 2 3 4 5 6, and I'll transfer over the cam profile from 1 2 3 4 5 6 on the prime circle. So this is the reference. Just cut an arc, that is 1 1 dash. Just take this as a reference. Just cut one more arc, 2 2 dash, 3 3 dash. So we'll get all these 6 points. 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. So I have given the note. Please read this note. From the displacement diagram, transfer the distances, that is 1 1 dash up to 6 6 dash with respect to the outstroke angle on these blue color inclined lines. These are radial lines and these are the inclined lines. So after the class, I'll share the notes. Just go through the notes. If any doubts, I'll clarify. Okay. In a similar manner,
Sir,
yeah.
we have to take arc from the prime circle.
This on the prime circle only. From this point 1, these points are on the prime circle itself. That is 1 2 3 4 5 6. Just cut an arc.
Okay.
Just take this as a reference. Just cut an arc. Just take this as a reference. Just cut an arc on these inclined lines. Is that clear? Yeah, I hope this is clear. Okay.
Yes, sir.
Okay. After that, in a similar manner, just follow the same steps. Just shift these dotted lines or the radial lines towards your right by 30 degrees. Just keep the protractor over here, and the center of the protractor has to be here. Just shift these dotted lines, the green dotted lines, towards right by 30 degrees. So this has to be 30 with respect to this dotted, and I can shift this also. So this is a 30. This is also 30 with respect to this dotted line, which is passing through 5th. Similar manner, I'll get all these inclined lines with respect to the radial lines passing through 6, 5, 4, 3, 2, 1, 0. After that, you can erase those dotted lines. Okay. So these are the inclined lines I got with respect to these radial lines. If you want, I'll show once again. So these are the radial lines passing through the point 6, 5, 4, 3, 2, 1, 0, and they are converging at the center of the circles. That's why I'm calling these as radial lines. Since again follow the same method, since the follower axis is shifted towards right by 30, I need to shift these radial lines towards right by 30. So I'll draw inclined by 30 degree. The first line, that is the 6th line. Similarly 5th, 4th, 3, 2, 1, 0. After that, just erase these dotted lines. Again, go to the displacement diagram, and corresponding to the written stroke, just copy the distances. That is the 6 to 6 dash and the 5 to 5 dash up to 1 to 1 dash. Just transfer the distances. Keep the compass here. Just cut an arc. Copy the distance from the displacement diagram. From the displacement diagram, just transfer the distances 6 6 dash 1 1 dash with respect to the written stroke, because you are indicating on the written stroke only, that is 6 degree. on these inclined lines, inclined green lines. Okay, so these are the inclined green lines. If you want, you can zoom in. Just take the reference as 6. Just cut an arc 6 6 dash, 5 5 dash, 4 4 dash up to last. This will be the last point. So after getting all these 12 points, that is 1 dash, 2 dash, 3 dash to this 0, just take these as a center, these intersection points as a center, just indicate the roller, okay, the radius of 15 mm. Just draw the roller, center of these red color dots, that is 1 dash, 2 dash, 3 dash, 4 dash. So you got all the rollers, and the center of these rollers are these intersection points on these inclined lines, 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash. Similar manner, just draw the rollers on these 6 dash, 5 dash, 4 dash with respect to the written stroke also. Okay, so you got all the rollers. Now starting from the first roller here, just draw the tangent. Just draw the curve just to be tangent to all these rollers. You can see the red color curve, which is tangent to the first roller, second, third, 4, 5, 6, and 6, 5, 4, 3, 2, 1. Just a tangent, and just complete this base circle. You have started from here like this, and you have to end again to the initial point. I'm not shown here, just complete this cam profile. Okay, so this is the cam profile. This red color curve is the cam profile. Okay, so this is the cam profile what I got from the solid edge. I've drawn this using the solid edge software, and this is the cam profile, same cam profile I got from the textbook. Okay, so you can see this is the follower, the roller at the end. Okay, and you can see this is the direction in which it is restricted to move in up and down direction. It will move in this direction only, not in this manner. Okay, it will not move vertically, it will move slightly towards right by 30 degrees. And this is a base circle, that is a 50 mm. So this is a prime circle, that is a 65 mm, and this is the cam profile. And just indicate the direction of rotation of the cam. It is clockwise, that's why I'm indicating the angles counterclockwise, that is 90 degree, 30, 60, and 180. So this completes the fourth module, that is cams. So I'll share these notes in the Google Classroom. If any doubts, please let me know in the next class. Okay. Thank you.